balanced pneumatic performance for the entire rig. When problems occur, the best solution may be to take advantage of the highly accurate computerized pneumatic and torque analysis services offered by Ferodo America. Torque balance involves the turning force at the S-cam. Input torque is determined by the amount of air pressure supplied to the brake chamber, the size of the chamber, and the length of the slack adjuster. To calculate the input torque, the air chamber size is multiplied by the slack adjuster length to determine the AL factor. Then the AL factor is multiplied by the air pressure and the cam lift factor. The answer is the input torque. For example, most trailers use a 30-inch air chamber with a 6-inch slack adjuster, yielding an AL factor of 180. With 20 psi at the air chamber, the force on the S-cam is 3,600 inch-pounds. And with a 0.5 S-cam lift factor, the torque is 1,800 inch-pounds. Changes that might seem insignificant can drastically change these calculations. For example, if the 6-inch slack adjuster in the previous example is replaced with a 5-inch slack, the AL factor drops from 180 to 150, reducing the force from 3,600 to 3,000, and the torque from 1,800 to 1,500, a 16.6% decrease. Keeping the slack at 6 inches and replacing the 30-inch chamber with a 24-inch chamber reduces the AL factor from 180 to 144, decreasing the force from 3,600 to 2,880, and the torque from 1,800 to 1,440, a 20% decrease. But even when pneumatic and torque balance have been achieved, mechanical factors can throw the brake system out of balance. Basically, mechanical balance concerns how brake systems handle heat. Brake blocks and drums stop a vehicle by converting motion energy into heat. The heat generated is transferred into the drums and ultimately dissipated into the air. Obviously, the amount of heat that different types of drums can store and dissipate is an important factor. Because cast and centrifuge drums dissipate heat differently, the two types should never be mixed on a tractor or trailer. However, one type can be used on the tractor and the other on the trailer. In a well-balanced system, the brakes on each wheel handle only their share of the workload and the heat. In an unbalanced system, the brakes on certain wheels are forced to work too hard. Heat in the affected blocks and drums builds faster than it can be dissipated. Braking effectiveness is reduced, and serious damage can occur to the blocks and drums. Making sure that all blocks fully contact drum surfaces during braking is one very important way to assure proper heat dissipation and workload distribution. Just how much the contact area can affect block temperature is shown in these calculations. Concentrating the same heat in 10 square inches of block instead of 40 increases the block temperature by 300% from 150 to 600 degrees. This added heat can cause blocks and drums to change and adversely affect braking performance and wear characteristics. Let's look at several conditions that can reduce this crucial block-to-drum contact. Out-of-round drums have been distorted into ovals. During braking, their narrowest diameters contact only the center of each shoe. When rotated to the widest diameter, they contact only the shoe edges. As a result, braking power is reduced, block wear is uneven, and accurate adjustment is impossible in both positions. Bell-mouth drums are spread at the outer edge, reducing the force of block contact. The result is reduced braking effectiveness and rapid uneven block wear. Drum surfaces can become cupped from foreign particle abrasion. The blocks wear into the drums, conforming to the concave shape. But if new blocks are installed using the same worn drum, contact is limited to the inner and outer edges. Again, the result is reduced braking effectiveness and rapid uneven block wear. Drum scoring damages installed block, then reduces contact with new replacement blocks and decreases their life expectancy. Any of these drum problems can be solved by turning the drums. That is, if the damage or distortion is minimal. But when a drum is machined beyond specification to solve a problem, the gap between the drum and new block is increased. And adjusting the brakes will only close the gap on the S-cam side, because the anchor pins on the other side are not adjustable. The inadvisable practice of installing oversized blocks seems to solve this problem. But since an S-cam is only capable of lifting brake shoes a half an inch, the block will eventually wear down and cause cam rollover to occur. The oversized blocks will have to be replaced before fully worn. A second factor that can affect mechanical balance is the block used. Each grade, brand, and edge code provides totally different braking capabilities over a range of operating temperatures. Even blocks with the same coefficient of friction on their edge codes can provide radically different levels of friction. So the exact same brand and block should be used on every wheel of a tractor or a trailer. Worn parts are another crucial factor in mechanical brake balance. Wear on a single part may seem insignificant, but a combination of worn anchor pins, loose cam bushings, tapered rollers, and stretched springs can add up to cause excess slack in the system. It's far more practical and cost-effective to replace each part every brake job. Proper linkage adjustment is just as important to mechanical balance. The length of all push rods and the angle of the slack adjuster to the push rod should be equal on all axles. Only a half to 3/4 of an inch of free play should be possible when the linkage is moved by hand. Brakes should be adjusted so that push rod travel is as short as possible without the blocks dragging. This also limits flex in the system. Eliminating just 20/1000ths of an inch of extra drum-to-shoe clearance can reduce the required chamber stroke by 50% at 20 psi. As we've seen, maintaining good mechanical, pneumatic, and torque balance requires care and attention to detail in specifying and replacing parts. When it comes to pneumatic balance, that means keeping the system clean and replacing valves, fittings, and lines with identical part numbers. For torque balance, it means using identically sized replacements for chambers and slack adjusters. And in mechanical balance, it means using the same blocks and types of drums on every tandem axle, replacing distorted or worn drums that cannot be machined in spec, installing exact replacements for all worn or damaged parts, and keeping all linkage properly adjusted. Other factors that must be considered in achieving overall brake system balance include tire size, cargo positioning, and the effect the suspension may have on load distribution. Brake balance is not always easily achieved, but the effort can pay off big in safety and savings. Contact your Ferodo America representative for information on brake balance seminars and field testing.